Hi friends, welcome to another lesson. We thank God for an opportunity to learn. We've done derivatives, but we've never touched on the one with a fraction, where the variable is a denominator, like here, x is a denominator. We've never really touched on these ones. So let's use this as an example. We need to find the derivative or f prime x from the first principles. Like I always advise, before you can start the first principles, derive it using the traditional method so you can know what the answer is. Let's go ahead and do that. I'll first simplify that because we can't derive now when x is a denominator. Remember, the numerator is always the coefficient, and then you bring x up. Now, the exponent here is going to be a negative exponent. So it was to the power 1. So we're going to have to the power negative 1. Beautiful. Now, let's go on and derive. It's going to be f prime of x equals to negative 1 multiplied by 5 is going to be minus 5 x to the power minus. Remember, we have to minus 1 from that. So it's going to be negative 2. Let's leave it with a positive exponent. It's going to be minus 5. Just like here, the numerator was a coefficient. So now the coefficient must become a numerator. And then we take x down. The negative exponent becomes positive. So that's the answer we are expecting at the end of the day. Okay. We expect to get the answer of negative 5 over x squared. Now let's use the first principles to get that answer. First thing first, write the formula f prime x equals to limit as h tends to 0. We're going to have f of x plus h minus f of x over h. Beautiful. We already have f of x, that's good. Now let's go on and work out f of x plus h. If we can do that, we've done half of the work. So f of x plus h equals to, you see, in the place of x, we have x plus h. So we're going to do that. In the place of x here, we are going to put f of x plus h. We're going to put x plus h. There you are. So now we have f of x plus h as well. Let's go and substitute into that formula, and then we do some algebra. Beautiful. So it says f prime x equals to limit as h tends to 0. It says f of x plus h. Remember, f of x plus h is that. So I'm going to go ahead and substitute f of x plus h minus f of x. F of x is the original equation. So we're going to have over 5 over x. Now, it says over h. Okay, over h. So since I'm already dealing with fractions here, allow me to use that over this here, like the traditional division sign, then over h. See, I've enclosed the numerator with brackets because the numerator is now inside brackets, because that divided by h must cover everything. Okay, that is why I put the brackets there. Equals to limit as h tends to 0. Now I'm going to go ahead and simplify what's inside the bracket. Okay, I'll go simplify what's inside the bracket, but I want us to look at something here. If I gave you 2 over 3 plus 1 over 4, and then I ask you to do this without using a calculator, simplify this without using a calculator, the best way to do this will be multiply your two denominators, 3 multiplied by 4, then cross multiply numerator and denominator like that. So 2 times 4 is going to be 8 plus 3 times the 1 is going to be 3. Then your answer was going to be 11 over 3 times 4 is 12. That will be your answer, right? So let's go and use that and apply that here. So it's going to be, we have two denominators, x plus h and x. Let's go ahead and multiply them like we did in the example. We're going to have x multiplied by x plus h Again, remember, cross multiply. 5 multiplied by x is going to be 5x. Cross multiply. Minus 5 multiplied by x plus h. I hope you're still with me. Divide by the h. Brilliant. Equals to limit as h tends to 0. We go ahead and multiply. 5x minus 5 multiplied by x is going to be minus 5x. Minus 5 multiplied by h is going to be minus 5h. Lovely. If you want, you can multiply the denominator as well. But let me just leave it. X plus h divided by h equals to limit as h tends to 0. Simplify. 5x are going to minus each other. We have minus 5h over x plus, there's no need now to put this. We have x into x plus h divided by h. Great. Remember from algebra, if you have two fractions, like 2 over 3 dividing another fraction, 1 over 4, you're allowed to change the division sign to multiplication and then flip the second fraction. So it's going to be 4 over 1. Okay? So we're going to apply that here. Keep in mind, the h is over 1 as well. Right? So let's go ahead and apply that. We have limit as h tends to 0. So it's minus 5h over x into x plus h multiplied by, now let's flip this too. The 1 is going to be on top and the h is going to be at the bottom. And then as soon as we do that, we realize that, okay, the h and the h can cancel each other. So we have limit as h tends to 0 minus 5 over x into x plus h. Great. Now this h, the divided by h, is gone. So all along we couldn't turn the h into 0 because the whole thing was going to be undefined. It was going to be invalid. Now we no longer worry because we are no longer dividing by h. We can turn the h into 0. So minus 5 over x into x plus 0. See, the h now is a 0. Now we have minus 5 over x. So x plus 0 is just x. Then minus 5 over x multiplied by x is x squared. And that's our answer. Looking exactly the same as that one. So that's how you approach this type of derivative. If you have your variable or your x as a denominator, do not panic. Work out your f of x plus h separately. Go back, substitute. Then you see the over. I think the secret is here. The over, that long division sign there, change it into the traditional division. It's going to make things look neat. And then you're able to solve. You can work it out anyhow, but I think it's neat when you do it this way. Okay, I hope you understand. If maybe we lost you somewhere, feel free to ask, and I'm going to assist you accordingly. Otherwise, my good friends, enjoy your practice, keep working hard. Your hard work will soon be rewarded. I'll see you in the next video. I can send you over. Amen. Thank you.